The civilization that builds around a star. There may be civilizations in the universe that no longer live on planets, not because they left their worlds behind, but because their worlds were no longer enough. What if the ultimate destiny of an advanced civilization is not to orbit a star, but to build around it? The energy ceiling problem. Every civilization faces the same fundamental limit: energy. On Earth, our entire modern world runs on a tiny fraction of the sunlight that reaches our planet. The sun releases more energy in 1 second than humanity has used in all of history. And yet, we capture almost none of it. As a civilization grows, more population, more computation, more infrastructure, its energy demand rises. Eventually, a planet becomes a constraint. If you want to grow beyond planetary limits, you must go to the source, the idea of a Dyson sphere. In 1960, physicist Freeman Dyson proposed a radical idea. If an advanced civilization needed vast amounts of energy, it could surround its star with structures designed to capture its output. Not a solid shell. That would be unstable and nearly impossible. But a swarm. Millions, even billions of solar collectors orbiting the star, harvesting its energy directly. This is what we now call a Dyson sphere. Though more accurately, it would be a Dyson swarm. A civilization that builds such a structure would no longer depend on a single planet. It would live in orbit around a star. Why a solid sphere won't work. A solid shell around a star sounds dramatic, but physics says no. A rigid shell would be gravitationally unstable. It would collapse inward or drift unpredictably, and the material requirements would be unimaginable. Instead, a Dyson swarm makes sense. Independent habitats, solar collectors in stable orbits, massive space-based infrastructure. Think not of a hollow ball, but of a dense halo of machines encircling a sun. Where would the materials come from? To build something on this scale, you need raw material. Planets are too valuable to dismantle, but Mercury, small, dense, rich in metals, close to the sun. Some theoretical models suggest that dismantling Mercury could provide enough material to build trillions of square kilometers of solar collectors. Asteroid mining would supplement this. Autonomous machines, self-replicating industrial systems, would construct new units in space, powered by the very star they orbit. It would not be built by humans in spacesuits. It would be built by machines over centuries or millennia. The Kardashev Scale. Russian astrophysicist Nikolai Kardashev proposed a way to classify civilizations. Type 1 harnesses all the energy of its planet. Type 2 harnesses all the energy of its star. Type 3 harnesses the energy of its entire galaxy. Humanity is currently around type 0.7. A Dyson swarm would mark the transition to type 2. It would mean a civilization had broken free from planetary limitation. What would it look like? From far away, a Dyson swarm would not shine brightly. It would block visible light from its star, but it would glow in infrared, because the energy it captures must eventually be re-radiated as heat. To distant observers, it might look like a dim star radiating excess infrared energy. And this gives us an idea. If such civilizations exist, we might detect them, not by seeing cities, but by seeing stars that look wrong. Have we seen one? Astronomers have searched for unusual infrared signatures. One famous case, Tabby's star, showed strange dimming patterns. Some speculated about alien megastructures, but natural explanations remain more likely. So far, we have found no confirmed Dyson spheres, but the search continues, because statistically, in a universe with hundreds of billions of galaxies, advanced civilizations may not be rare. The psychological shift. A civilization that builds around its star has fundamentally changed its relationship with reality. It no longer thinks in terms of countries, continents, or even planets. Its scale is stellar. Its infrastructure spans millions of kilometers. Its survival depends not on a biosphere, but on orbital stability. It has stepped into cosmic engineering. Closing. We look at the night sky and see distant stars, but some of them may not be untouched. Some may be surrounded by civilizations that outgrew their worlds. If humanity survives long enough, and if our ambitions remain, we may one day face the same choice: stay confined to a planet, or build around a star, and in doing so, redefine what it means to be a civilization. If you want more research-driven visual explorations like this, subscribe to Frontiers of Vision.